Welcome to our final year project, EnFluent. EnFluent is a personalized language learning platform built with an adaptive learning management system. To start, let's talk about the problem we're solving. First, traditional learning methods have many limitations. They often fail to meet the unique needs of each learner. Second, there's a lack of personalization. Most systems don't adapt to how a learner progresses. Third, the one-size-fits-all approach just doesn't work. Every learner is different. And finally, current systems don't adjust or evolve based on how the learner improves over time. Now let's go over our main objectives. Our first goal is to enhance engagement. We do this using interactive avatars and IoT-based data, creating immersive learning experiences. Next, we focus on real-time adaptation, personalizing lessons based on live data from the learner. We also promote interactive learning, encouraging active participation to make learning more effective and enjoyable. And finally, we aim to improve learning outcomes by increasing engagement and making learning more tailored to each user. Moving on to our project deliverables. First, we've developed an automatic grading and feedback system. It evaluates reading, writing, speaking, and listening skills, especially useful for IELTS learners. Second, we use IoT data, like smartwatches and webcams, to detect and track learner engagement in real time. Third, we've created an interactive AI avatar and chatbot, giving learners a conversational way to practice and learn. And last, we're delivering a complete language learning platform, designed to be powerful, personalized, and easy to use. Now let's take a look at the system architecture of EnFluent. Users can log into the platform either as an admin or as a student. Admins, such as course creators, can build and manage courses. Inside each course, they can upload materials like videos, documents, and assignments. For speaking-focused courses, they can even add speaking tasks using our integrated AI chat avatar. They can also test the built-in AI grading system and access valuable user analytics, like engagement levels and student activity for each course. Students enter the system through a different flow. Once a student logs in, they begin with an onboarding test, which evaluates their reading, listening, writing, and speaking skills. Based on their scores, a learner profile is created. This profile is used by our course recommendation engine to suggest personalized courses from the LMS. Each course includes assignments and quizzes, all automatically graded. To improve speaking skills, students use our interactive AI chat avatar, which closely simulates the real IELTS speaking test environment. They also have access to a smart chatbot, which answers course-specific questions and helps them review materials. To track focus and involvement, EnFluent uses IoT data, like webcam footage and smartwatch inputs, to detect engagement in real time. And finally, each course ends with a final test that updates the learner's band scores and profile. Now let's explore the course recommendation system. After finishing the onboarding or final test, the learner's band scores are updated. The system then filters the course catalog and recommends the most suitable courses, shown in the Personalized Recommendations section. EnFluent also includes a smart automatic grading system for all 4 IELTS components: reading, listening, writing, and speaking. Starting with reading, learners answer IELTS-style questions based on a reading passage. There are 3 sections and 40 questions, with 14 different question types, like multiple choice and true, false, not given. Grading here is straightforward. Answers are directly compared to the correct ones. The listening module works similarly. Students listen to audio clips and answer short questions across 4 sections. Again, Automatic grading compares the user's responses with the correct answers, covering 11 different question types. Now the writing module. Here, we evaluate how well users can express ideas. There are 2 tasks. The first asks users to explain visual data like charts or maps. The second is an essay on a given topic. The total time is 60 minutes. This is where things get more advanced. We use a large language model to grade the written answers. Here's how the writing grading works. We take the task, the student's answer, and a fine-tuned prompt, and send them to Azure GPT-4. It returns a detailed result, including a score, personalized feedback, and an improved sample answer. We designed the prompt using IELTS grading criteria, such as coherence, grammar, vocabulary, and task achievement. The model uses a probabilistic method to estimate band scores consistently, making the results reliable and accurate. The AI chat avatar in the EnFluent project creates an experience that feels like talking to a real person. Its purpose is to help users build confidence in speaking English, especially for situations like the IELTS speaking test. The avatar listens to the user's voice and responds naturally, just like a human conversation partner. It moves its lips in sync with the spoken words and uses lifelike facial expressions and body animations, making the interaction feel alive and engaging. Because it responds quickly and smoothly, users don't feel like they're talking to a machine. Whether it's a formal IELTS-style session or a casual chat with a friendly character, the avatar keeps the learner motivated and focused, improving fluency in a natural way. Now let's take the IELTS test.
Where are you from?
I am from Sri Lanka.
That's interesting. Tell me, what do you usually do on weekends?
On weekends, I usually try to relax and recharge after a busy week. So I often spend time with my friends and family, and maybe go out for a meal or walk in the park. That's what I like to do in the weekends.
Thank you. That concludes the speaking test. Do you have any questions for me?
No, thank you. We can end the test.
This is the end of the test. We now have the IELTS speaking band score, along with a pronunciation report for each word. We also have the evaluation transcript here. Now let's dive deeper into our intelligent chatbots. This slide explains how the course-based chatbot works. When a document is uploaded, it is first sent to the backend server. There, it's broken down into smaller text chunks. Each chunk is converted into a vector using OpenAI's embedding model, and these vectors along with the chunks, are stored in a vector database. When a student types a question in the chat, the backend creates a vector for that message too. It then finds the most similar chunks in the vector database. The student's question and the matched chunks are then sent to Azure GPT-4, which generates a smart response. Finally, the response and the source links are sent back to the user on the front end, making the learning experience both helpful and traceable. Here's how the chatbot works when it's based on a video. When a video is uploaded, it's first converted into audio. That audio is then transcribed using the Whisper model. The transcript is stored in the database. When the student sends a message, the chatbot fetches that transcript, combines it with the student's question, and sends both to Azure GPT-4. The model generates a response, which is shown on the front end, making it easy for students to interact with video content using natural language. Now let's move on to the IoT integration part. Here's a look at the IoT data flow in EnFluent. We use the webcam to take a photo of the student every 6 seconds. Each image is sent to our backend server and passed through a machine learning model that detects engagement levels. The engagement status is then saved in the database. At the same time, a smartwatch continuously measures heart rate data. This data is transferred to an Android device via Bluetooth and stored in the Health Connect app. To move that data to the cloud, we created a custom app called HC Gateway, which syncs the heart rate data with our backend. By combining both webcam and heart rate data, we calculate real-time engagement, which is visualized in the student dashboard. We apply the Bayevsky stress method, which calculates stress based on heart rate variability. This method is known for its reliability and scientific accuracy. We trained a custom YOLOV11 model using the Effective States computer vision dataset. YOLOV 11 performed the best in detecting engagement by analyzing facial cues and head position. So, this is EnFluent, a smarter, more personalized way to learn languages. Thank you for watching.